We're going to know and use the angle addition postulate, which we've used. We're going to know and use the reflexive, symmetric, and transitive properties of angle congruence. They work just like the segment congruence versions. Know and use the vertical angles theorem. We've done that. Know and use the supplement theorem. We've done that. Complement theorem. We've done that. Congruent supplements and congruent complements. We'll have to talk about those. And right angle theorems. I think we've probably used all of those at some point. So here we go. On page 149, all right, the angle addition postulate is for angles what the segment addition postulate is for segments. It says if you have a point in the interior of an angle, like D is for angle ABC, and then you make that ray through D, and you've divided the angle ABC into two angles, not two congruent angles, but into two angles. If you add the measures of those two new angles, they must equal the measure of angle ABC. For instance, if the measure of angle ABD was, let's say, 30, and the measure of angle CBD was 20, wouldn't that mean that the measure of angle ABC has to be 50? That's the way the angle addition postulate works. Let's do a couple of examples. Write these down. We'll just call this one example 1. All right, since we've got a large angle here, and we can name it if we want. We can name it angle A, B, C. Then we've got a point D with that ray through it. So we've divided angle ABC up into two angles, not two congruent angles, two angles. So if we add the measures of the two smaller angles together, that sum must be the measure of angle ABC. That's what the angle addition postulate tells us. Okay? So we take the measure of angle ABD, 3x plus 15, add to it the measure of angle CBD, 5x minus 5, and the sum must equal the measure of angle ABC, 12x minus 14. All right? All right, so we can solve this. 3x plus 5x is 15 minus 5. Then leave the other side alone. All right, let's subtract 8x from both sides. So we'll get 10 equals 4x minus 14. Let's add 14 to both sides. 24 equals 4x. Divide both sides by 4. And we found x. Now, you'll have to pay attention to directions. Now that we've found x, maybe we're finished. Maybe we need to find the measures of these other angles. It all depends on what the directions say. Let's say they tell us to find the measure of angle ABD. Well, angle ABD has a measure of 3x plus 15. So that'd be 3 times 6 plus 15. So what's 18 plus 15? So we'd get 33. And then we could do the same thing with the others if we want to, couldn't we? Okay? So have we worked problems like this before? Yes, we have. All right, so now that I've convinced you, I hope, that we've done this kind of thing before, I want to look more closely at the theorem so we can get the wording down. So D is in the interior of angle ABC. Let's think of it this way. Let's say if D is in the interior of angle ABC, then the measure of angle ABD, this one, plus the measure of angle DBC, this one, equals the measure of angle ABC, this one. Okay? Remember how the if and only if works? We could also think of this as if the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC, then D is in the interior of angle ABC. It's kind of like with the segment addition postulate, we had to have between, Y has to be between X and Z for the segment addition postulate to hold. Well, D has to be in the interior of angle ABC for the angle addition postulate to hold. All right, if D was on one of the sides, that's no good, right? So that's what's got to happen. Does that make sense? Any questions on the angle addition postulate? All right. Find X. Anybody get the same thing I got? Okay. And then if we wanted to find individual measures of angles, we can do that, right? Just by substituting 11 in for X. All right, so I think you'll find the angle addition postulate easy to work with. You'll have to do some algebra, but that shouldn't be that big a deal. Now, the supplement theorem. All right, it says the angle addition postulate can be used with other angle relationships to provide additional theorems relating to angles. So like I've told you before, theorems are laws of mathematics that can be proven. Okay? Now, we'll come back a little bit later and we'll prove some of these theorems ourselves. We're not really ready to prove theorems yet. Okay? But some of these we can prove. Others, it takes actual mathematicians to prove. Some of them we will know enough in a couple months to be able to do. Okay? So the supplement theorem is an idea we're familiar with. If two angles form a linear pair, then they are supplementary angles. I think before we had a sentence that said the angles in a linear pair are supplementary. Exact same idea, isn't it? So in this figure here, we can identify that angle 1 and angle 2 form a linear pair. The supplement theorem says that means they are supplementary angles. And then we know what that means. Supplementary angles are two angles with measures that have a sum of 180. So that means we can set the measure of angle 1 plus the measure of angle 2 equal to 180. So there's a lot of thought that goes into a fairly, it seems simple, it seems like one sentence, but it takes a lot more thought than that to actually use it. Okay? But we have used that, haven't we? Nothing new there. Okay? The complement, and by the way, theorems that have names, we can use those names to communicate. We can say to each other, hey, if they're a linear pair, that means they're supplementary. We can also say, remember the supplement theorem? That's what I'm using here. So, I'm not going to quiz you over what the names of the theorems are, but that's a way we can communicate is by using the names. The complement theorem. We never actually said this as a statement, but we did use it. It says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. What we usually had before is we'd have this kind of a diagram, and then they'd usually put the little perpendicular over here, and then we'd say, oh, okay, if that's a right angle over on the left, then we know it's also a right angle over here, which means if I add these two measures together, I have to get 90. We kind of explained it instead of using a theorem. Well, now the theorem says if the non-common sides of two adjacent angles, so angle 1 and angle 2 are adjacent angles. The non-common sides are this ray and this ray. So if the non-common sides of two adjacent angles form a right angle, then we've already decided weeks ago that angle 1 and angle 2, when you add their measures, you get 90. Isn't that the definition of complementary angles? So the statement says, or the theorem says, then the angles are complementary angles, which we know means when we add their measures, you get 90. So the complement theorem is an idea we've used, even if we never said it just like this. All right, you hanging in there with me? All right, I thought so. Let's do a few from page 154. Find the measure of each numbered angle and name the theorems that justify your work. All right, so for number 1, we'll be dealing with, let's see, how did I put this? I attached them. All right, for number 1 and for number 2, we're going to be dealing with the figure over here on the left, aren't we? Because that's where angle 1, 2, and 3 are. So let's look at this. For number 1, we're supposed to find the measure of each numbered angle. Okay. What's the measure of angle 1? Measure of angle 1 equals 90. It says name the theorem that justifies that. I don't think any of the theorems we've talked about they actually do. I think I might even just say definition of perpendicular lines. Okay. Now we're supposed to find, well, they give us the measure of angle 2. The measure of angle 2 is 26. What's the measure of angle 3 have to be? Has to be 64. How come? Because the angle 2 and angle 3 have to be complementary, don't they? The complement theorem says so. Their non-common sides, angle 2 and angle 3 are adjacent angles whose non-common sides form a right angle, so angle 2 and angle 3 are complementary. We know that that means their measures add up to 90, and if one of them's 26, the other one's got to be whatever 90 minus 26 is. 64. And we used the complement theorem. Feel free to use the same abbreviations that I use. Don't make your own up, but use what I use. Perp for perpendicular, def for definition, comp for complementary, THM for theorem. Everybody uses those. Okay? All right, that's it. That's all we can do for number 1. We good? Number 2. All right, we start over because they give us new measures. The measure of angle 2 is x. The measure of angle 3 is x minus 16. Well, what's the measure of angle 1? 90. All right, now before I can get the measure of angle 2 and the measure of angle 3, I need to figure out what x equals. Well, according to what theorem? The complement theorem. Angle 2 and angle 3 are complementary angles. So we're using the complement theorem. And then let's solve for x. That would be 2x minus 16 equals 90. So 2x equals 106, and x equals 53. So then what's the measure of angle 2? 53. What's the measure of angle 3? 37. Either by doing x minus 16 or by doing 90 minus 53. All right, so that was the complement theorem that gave us all that. Make sense? All right. For number 3, I'm going to erase what I have here so I can see the figure while I'm writing. Everybody got this written down? Oh, come on. All right, number 3. Now, the measure of angle 4 equals 2x. The measure of angle 5 equals x plus 9. So of the theorems we've talked about already today, which one applies to this situation? The supplement theorem. These two angles are a linear pair, so they're supplementary to each other. So 2x plus x plus 9 equals 180. That's using the supplement theorem. We can solve for x, then we can tell what the angles are. So do that. Solve for x. Did we all get the same x? I got 57. Did you get 57? All right. Now, we need to get the measure of angle 4. That'll be 2 times 57. So what's the measure of angle 4? 114. And then we can get angle 5 a couple different ways. It looks to me like the simplest way is probably just to use the x plus 9. All right. So the measure of angle 5 would be 57 plus 9. What's that? And then you can always double check yourself. They're supposed to be supplementary. Do 114 and 66 have a sum of 180? Yeah. So I'm feeling pretty good about that one. And we use the supplement theorem. Any questions on 3? All right, do 4 all by yourself. I know, it's kind of scary. Questions? Okay. All right, and then here we have the properties we talked about yesterday. We talked about these properties with numbers. We talked about these properties with segments. They apply to angles as well. And, you know, I think they're, even though this is a theorem, which means we can prove these properties, you know, these are fairly apparent, I think. The reflexive property of congruence says that angle 1 is congruent to angle 1. An angle has to be congruent to itself. It has to have the same measure as itself. I hope, because if it doesn't, my whole worldview falls apart. All right? The symmetric property of congruence. If you write angle 1 is congruent to angle 2, and then I write angle 2 is congruent to angle 1, haven't we conveyed the same meaning? Yes, that those two angles are congruent to each other. So the symmetric property works for congruent angles. And then the transitive property. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, that means you have 3 congruent angles, right? So can't you then pair them up any way you want to? One of the ways being, then angle 1 is congruent to angle 3. Okay? Any trouble with those? All right. Now, this one takes just a little bit more thinking. These two. We have the congruent supplements theorem and the congruent complements theorem. Once you understand one, you will understand the other. So let's talk about the congruent supplements theorem. It says angles supplementary to the same angle or to congruent angles. Let's skip that part for a minute. Angles supplementary to the same angle are congruent. So look at the figure. In the figure, we're going to say that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2. The congruent supplements theorem says that means that angle 1 is congruent to angle 3. Well, look, it's got to work that way. Let's say the measure of angle 2 is 50, and let's pretend that's not there. If angle 1 and angle 2 are supplementary, what's the measure of angle 1 have to be? It has to be 130. If angle 3 and angle 2 are supplementary, what's the measure of angle 3 have to be? So isn't angle 1 congruent to angle 3? Okay. So if two angles are supplementary to the same angle, those two angles are congruent to each other. And now the part I covered up, or two congruent angles. So let's say there was an angle 4 that was 50. And we said, all right, angle 1 is supplementary to angle 2. Angle 1's got to be 130. Angle 3 is supplementary to angle 4. So it's got to be 130. So didn't we still end up with angle 1 congruent to angle 3? All right, the congruent complements theorem is the same thing with complementary angles. Angles complementary to the same angle or two congruent angles are congruent. So if angle 4 is complementary to angle 5 and angle 6 is complementary to angle 5, then 4 must be congruent to 6. Put numbers on there and it becomes obvious. If the measure of angle 5 is 70 and angle 4 is complementary to it, it's got to be 20. Angle 6 is also complementary to angle 5, it's also got to be 20. Angle 4 is congruent to angle 6. Questions? The old standby, vertical angles theorem. Before we had a sentence that said vertical angles are congruent. Now we have something called the vertical angles theorem, which says if two angles are vertical angles, then they are congruent. Now, when we use this as a justification, like on the first few problems we did on page 154, we had to name the theorem we used. You can call it the vertical angles theorem, and that's because that's its name. You can also just write out vertical angles are congruent because that's just about as fast. I'll do both things. You may ask me, what's the justification for this? I may say vertical angles theorem. You say, oh yeah. I may say vertical angles are congruent. You'll say, oh yeah. Either way, right? I don't care. We're going to call it both things. We're going to actually state it. Vertical angles are congruent. We're going to call it its name, vertical angles theorem. Bet you can't do number 12. The directions told us to find the measure of each numbered angle. So when I found x, I wasn't finished. I judged that finding the measure of angle 3 was a little bit simpler than finding the measure of angle 4, so that's when I found. They got to be congruent to each other, so I kind of went for it. Now, if I blew it on finding the measure of angle 3, I also missed the measure of angle 4. But I went for it. Okay? And then we're supposed to name the theorems used to justify your work. Well, it was all based on the vertical angles theorem, wasn't it? Okay? That's how we knew to set those measures equal. All right. Any questions? All right. Then we have some right angle theorems. These are on page 153. Some of these we've already talked about. Perpendicular lines intersect to form 4 right angles. All right, what we had before was the definition of perpendicular, which said lines or parts of lines that form right angles are called perpendicular. Well, now we're specifically saying that there are 4 of them, and we'd talked about that, how every angle formed by those 2 intersecting lines is a right angle. Okay? Now, that doesn't mean that if I put one in like that, that angle 5 and angle 6 are right angles, does it? Because that's not part of the perpendicular lines. That was an extra ray I drew in. Okay? Next one, all right angles are congruent. Well, of course they are, because the measure of every right angle is 90 degrees. So anytime 2 angles have the same measure, we call them congruent. So all the right angles have to be congruent to all the other right angles. Perpendicular lines form congruent adjacent angles. We've talked about that one. Seems kind of odd. Sometimes you have theorems. What's the best way to say this? Sometimes you come up with a theorem just to use it later on to prove another theorem. Because in and of itself, that doesn't seem all that important, okay, to know that the adjacent angles are congruent to each other, in that we've already said that all 4 of them are right angles and that all right angles are congruent. We already know all of these are congruent to each other. The first 2 theorems take care of that. So, I don't know, maybe we'll use that one later on to prove something else. We'll see. And by later on, I mean later on. All right, the next one. If 2 angles are congruent and supplementary, then each angle is a right angle. If they're congruent, their measures are equal. If they're supplementary, their measures have a sum of 180. So kind of go the other way around. If they have a sum of 180 and they're the same, don't they both have to be half of 180? So they're both 90. And if they're both 90, then they're both a right angle. So each angle is a right angle. If 2 congruent angles form a linear pair, then they are right angles. Isn't that saying the same thing as the one above it did? Almost. Okay? Instead of being told they're supplementary, we're told they're a linear pair, which we know means they're supplementary, which then means we use this theorem to prove that theorem. Okay? All right, you still hanging with me? All right. I took these off of a worksheet. Let's just refresh our memories. If we do number 7 here, y'all just help me out. Y'all help me figure it out, and you won't have to write it down. If the measure of angle FGE equals 5x plus 10, FGE right here, 5x plus 10, find the value of x so that line FC is perpendicular to line AE. So, if 2 lines are perpendicular, what are all 4 of the angles? Right angles. So we've done this before, right? We just take the 5x plus 10, set it equal to 90 because the 5x plus 10 must be the measure of a right angle. And then we solve. What do I do? And x equals. Okay. On the next one. If the measure of angle BGC is 16x minus 4, and the measure of angle CGD is 2x plus, 13, Find the value of x so that angle BGD is a right angle. So, if we have a pair of adjacent angles and the non-common sides form a right angle, those two adjacent angles must be complementary, add up to 90. So we'll take 16x minus 4 plus 2x plus 13, make it equal 90. And we did equations like this already, right, before this section, because they made sense. All right, well, 16x plus 2x gives me, come on, play along, 18x, negative 4 plus 13. Now what? And we get okay. Ooh, here's a blast from the past. Can we assume? All right, angle NQO, that one, and angle OQP, this one, are complementary. Do we know that those two angles are complementary? No, because we don't have perpendicular marks, do we? So, no, the explanation is don't assume measures. Don't assume that because they look like they add up to 90 that they do. All right? Angle SRQ, that one, and angle QRP, this one, is a linear pair. Yes, because we can say if it looks like a line, it's a line. So yes, the explanation is if it looks like a line, it's a line. All right? And here's your assignment. Page 154, 1 through 4, 8 through 13, 36 through 39, and 41 through 44.